Within the secure walls of Bioforge, a specialized genetic engineering and synthetic biology laboratory, a radical new system was conceived. The core idea was audacious, almost unthinkable: to engineer a friendly bacterium that lives inside a tree, turning the entire organism into a living, breathing biorefinery. But this presented a critical ethical choice. The initial drain-the-host design, a purely parasitic model, was formally rejected on principle. We chose a superior, more elegant path, the mutualist model. The directive was clear: help the tree, while the tree helps us. The result was Project Diesel Sequoia Endo Fuel version 1.0. A genetically engineered endophyte designed not as a parasite, but as a true symbiont, forming a lasting, beneficial partnership with the magnificent Sequoia. Trees. This is the foundation for a sustainable, globally distributed, and truly carbon-negative biofuel production platform that grows itself, powered by nature. Module 1. The chassis and stealth system. The foundation of our symbiont is a native, friendly bacterium already living inside Sequoia dendron giganteum. This provides an immune-compatible chassis and a perfect built-in camouflage, allowing the tree's defenses to accept it without issue. We aren't dropping a stranger into the ecosystem. We are simply upgrading a trusted neighbor. Module 2. The Mutualist Engine. This module functions as an onboard fertilizer factory. Using the complete NIF gene cluster, the symbiont actively converts atmospheric nitrogen into bioavailable ammonia, fertilizing the tree from within. The tree grows stronger, healthier, and more resilient. In short, we feed the host. Module 3. The Safety System. Nitrogenase, the critical enzyme that fixes nitrogen, is extremely sensitive to oxygen. Module 3 provides a two-layer shield: oxygen-binding proteins like phyci, and finely tuned respiratory chains that keep local oxygen concentrations low. This robust, multi-stage defense system keeps the mutualist engine alive and highly efficient. Module 4. The Fuel Refinery. Here, the science feels like heresy. We integrate known genes from the mevalinate pathway, found in plants like Copafera, to construct a hydrocarbon factory inside the microbe. The result: our symbiont converts tree-supplied sugars into pure diesel-like molecules, creating a fuel that is drop-in compatible with existing engines and infrastructure. The tree remains a tree, but now it's also a living, breathing, carbon-negative refinery. Scientific board evaluation, innovation documentation, and intellectual property timestamp. Formal record, October 20th, 2025. This document memorializes a decision point of historic consequence, a pivot point for global energy. Executive summary for the board. You are being asked to authorize funding for what may be the most consequential biotechnology project of the 21st century. A project that redefines the relationship between industry and ecology, transforming a traditionally extractive process into a regenerative one. The promise: access to potential trillion-gallon fuel reserves, achieved through a carbon-negative production cycle that requires zero land competition with food crops. This creates a powerful economic engine with dual revenue streams, not just from fuel sales, but from verifiable high-integrity carbon credits generated by strengthening the world's forests. The revolutionary insight: Endo Fuel version 1.0 is not speculative. It is the modular integration of proven genetic systems. We are not inventing each piece from scratch. We are assembling a powerful new whole from well-understood, de-risked components with established precedents in nitrogen fixation, oxygen protection, and hydrocarbon production. Prior art includes the successful commercial production of artemisinin, farnesene for jet fuel, and other terpenoid hydrocarbons, which have already validated the mevalinate pathway at industrial scales. Furthermore, the multi-billion-dollar biofertilizer industry proves the viability of endophyte colonization and delivery at scale, a critical component of our strategy. The innovation is not a leap into the unknown, but a strategic integration of these well-validated genetic modules into a single mutualistic package. The question before you is not one of fantasy, but of execution. Is the technical feasibility sufficiently demonstrated to justify the billion to trillion-dollar investment required to build a global distributed, carbon-negative, Refinery rooted in place. The science says yes. The engineering is ready. Roadmap. Phase 1, chassis plus NIP validated. Phase 2, oxygen shield and fuel yields. Phase 3, field trials and scale. Budget 50 to 1. Partners, Synbio leaders, agencies, forestry, energy.